Welcome to qnawire.
In this problem, we need to find h from the surface. So, the height h from the surface at which the bullet is fired in the two given conditions. So, for letter A, if upon impact, the disc is to roll without sliding. And for letter B, if upon impact, the disc slides without rolling. So, I have here a sketch of the problem. So, a bullet with mass m was fired at a velocity v sub o at an unknown height h into a disc with mass m and radius r initially at rest. So this is what you can see in the first part of the sketch. So the bullet penetrates the disc, and in the second part of the sketch, you can see the forces acting on the bullet upon impact. So that's the weight, the normal force, and the friction in the opposite direction. So the impact causes the disc to rotate with an angular velocity omega, and the center G moves at a velocity v sub 1. So, applying the impulse momentum theorem, so we'll have an equation along y and an equation along x. So, along y, so our equation would be 0 plus the normal force times the time interval minus the weight times again the time interval equals 0. So this means that the normal force is equal to the weight. Now, along x, our equation is mv sub o minus the friction force, so F, then times the time interval equals the mass of the disc times v sub 1. So since n is equal to the normal force is equal to the weight, and the friction force is, as we know, equal to the coefficient times the normal force, or mu n, our equation would become, so m v sub o minus the coefficient times the weight times the time interval equals m times v sub 1. So, since delta t here is approximately equal to 0, so this will be reduced to, so m v sub o equals m v sub 1. So, solving for v sub 1, so we'll see that v sub 1 is equal to the mass of the bullet over the mass of the disc times v sub o. There. So we can write another equation now for the moments about point G. So taking the counterclockwise direction as positive. So our equation would be, so m v sub o times r minus h equals, so minus r times the coefficient times the weight times the time interval equals I omega sub 1. So again, delta t here is approximately equal to 0, so this will be reduced to, so m times v sub o times r minus h equals I omega sub 1. So the moment of inertia of a solid disk is given by, so I equals 1/2 mr squared. So, substituting that in the equation, so our equation becomes, so m times v sub o times r minus h equals, so 1/2 mr squared omega sub 1. So, solving for omega, so we'll have, so omega sub 1 equals 2 mvo r minus h all over mr squared. There. So that's our equation for the angular velocity. Now, so let us solve for the h for part A. So again, the condition for part A is if the disk rolls without sliding after the impact. So if that's the case, we'll have omega sub 1, whose direction is clockwise. The positive direction is clockwise. And we'll have V sub 1 equals R omega sub 1. So we can substitute our equation for we can also substitute our equation for V sub 1 earlier. So hence we'll have V sub 1 is equal to actually negative R omega sub 1 because of the direction. So our equation for V sub 1 earlier is M over, or the mass of the bullet over the mass of the disk times V sub O equals negative R, and then substituting our equation for omega sub 1, so that would be 2 M V sub O, then R times R minus H, all over MR squared. So, simplifying the equation, you will see that you can factor out M over M V sub O for both sides. So, the left-hand side would be equal to 1. And then, we can cancel out R here. So, we'll have R in the denominator. So, the right-hand side would be equal to negative 2. So, R minus H all over R. So, this would be R equals negative 2R plus 2H. So, this would be 3R equals 2H. Then finally, H is equal to 3 over 2 times R. So, this is our H for part A. Now, for part B, the condition is the disk slides without rotating. So, if that's the case, our omega is 0. So, our equation for omega would be 0 equals 2m V sub O R minus H all over m R squared. So, this would result into H equals R. So, the H is equal to, the height H is equal to the radius.